Good evening, dear students. Today I am going to start the session. Good evening, dear students. Today I am going to the session First PUC Math Revision Class 2. The topic is Relations and Functions. Here today I am going to explain 3 marks and 5 marks questions. In the previous session, I have done First PUC Math Revision Class 1. I explained 1 mark and 2 marks questions in the topic of relations and functions. Today I am going to explain 3 marks and 5 marks questions. So it helps you a lot to improve your score in first PUC. So regularly you attend the classes, definitely you have the chance to improve your score. Right. You can see now I am going to start now the class. Everyone can see this. So now I am going to start the class. 3 marks questions. The given a is equal to 1, 2, 3 and 14. Define a relation R from a to a. R is equal to set of x comma y such that 3x minus y equal to 0. xy belongs to a. Write R in roster form. Also write its domain and range. This is the important question. Under 3 marks they may ask this question. Under 3 marks they may ask this question. Say this question always try to write this one. 3 marks they may ask this problem. Right. Now see here on 3 marks. A equal 1, 2, 3 and 14. Define a relation R from a to a by R equal to x comma y such that 3x minus y equal to 0. xy belongs to a. So the given relation you can see the given R is equal to set of x comma y. The given relation R is equal to set of x comma y such that 3x minus y equal to 0. xy belongs to a. xy belongs to a. Correct, like this they are given. So from this can you write 3x minus y equal to 0 means 3x minus y equal to 0. I can write y is equal to 3x. Correct, I can express y is equal to 3x. Now you can see that I can express y is equal to 3x. So because y is equal to 3x I can write. That means you take the values, these are the values of x comma belongs to a only. Then I can write R is equal to set of, I can write now. See that when I have taken y is equal to 3x, I can write now, put x is equal to 1 comma 3. Put x is equal to 2, you will get 2 comma 6, 3 comma, just you substitute the values, 1 comma 3, 2 comma 6, x is equal to 2, 3 to 6, 3 comma 9, 4 comma 12. If I take 5, if I take x is equal to 5, it comes 15, 15 is not there in a. So you can stop with only 4 comma 12. So this is, I can write here 1, 3, 2, 6, 3, 9, 4 comma 12. Now I can write domain and range. See now I can write domain and range now. When I written like this, R is equal to x comma y, I written 3x minus y equal to 0. Here you write 3x minus y equal to y is equal to 3x. From this I have written this. So here the values of x and y should belong to a only. Take x value 1, 3 into 1, 3. X value 2, 2 comma 6. X value 3, 3 comma 9, 4 comma 12. If I take 5, 15. So 15 doesn't belong to a. So this is your relation R. This is roster form. They are asking domain and range. Domain means the set of first elements of the ordered pairs. I can write domain equal to set of 1, 2, 3, 4. This element is 1, 2, 3, 4. In the ordered pairs, The set of first elements is called domain. Next, range. When they are talking range, you take second elements 3, 6, 9, 12. This is range. 3, 6, 9, 12. Like this it gives range. I have written domain is 1, 2, 3, 4. Range is equal to 3, 6, 9, 12. 3, 6, 9, 12. Now, you see, I hope you understood this. I will explain the next one. I can repeat. If any doubt, please let me know in the chat box. Even respond to the chat box. Send me your name also. I should attend who are attending class. Please send me your names in the chat box. You can also do that. Please send me the names in the chat box. Now, see the next problem. Given A is equal to a set of 1, 2, 3, 4, 5, 6. Let R be the relation on A defined by A is equal to 1, 2, 3, 4, 5, 6. R be the relation on A defined by R equal to A comma B. AB belongs to A. B is exactly divisible by A. So they are given, this is the problem. This is also one of the 3 marks problem. A is given 1, 2, 3, 4, 5, 6. Relation R on A on the set is defined by A comma B. AB belongs to A and B is exactly divisible by A. You should write B is exactly divisible by A. Then we will write now R value will write. So B is exactly divisible by A. So you can write 1, 2, 1, 3 because B is exactly divisible by because A is 1. 1, 2, 1. You can think like this 1, 2, 1, 3. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, correct? It divides. They're saying here 1, 2, 3, 4, 5, 6. B is exactly divisible by A. Even I can write 1, 1 also can write here, correct? I can include 1, 1 also. 1, 1, 1, 2. Is clear? 1, 1, 1, 2. 1, 3, correct. 1, 3, 1, 4, 1, 5, 1, 6. Next I can write 2, 4, 2, 4, correct. 2, 4, 2, 6, 2, 4, 2, 6. Because 2, 4, 2, 6. Next I can write 2, 4, 2, 6. Even 2, 2 also can write, correct. Even 2, 2 I can write here. I can include 2, 2 also, right. Divides 2, 2. So 2, 2, 2, 4. 2, 6, next 3, 3, 3, 6, correct, it divides 3, 6 and 4, 4, 5, 5, 6, 6. You will get like this. Sir, why are doing so many things here? Because B is exactly divisible by A. B, 1 is divisible by 1, 2 is divisible by 1, 3 is divisible by 1, 4 is divisible by 1, 5 is divisible by 1. 6 is divisible by 1, 2 divides 2, 4 divisible by 2, 6 is divisible by 2, 3 divides 3, 6 is divisible by 3, 4 is divisible by 4, 5 is divisible by 5, 6 is divisible by 6. Like this I have taken all the elements. From this they are asking what is the domain. So when they are asking domain now, you can see here. Domain with the set of first elements. They are talking about domain with the set of first elements. Domain set of first, you see first elements all 1 here, 2 is here, 3 is here, 4 is here, 5, 6, 1, 2, 3, 4, 5, 6. This is domain. Next they are asking range. So what is the range here? When they are talking range here, range is set of second elements. So this is second elements. All elements are here 1, 2, 3, 4, 5, 6. In this problem, domain and range both are equal. Domain and range both are equal in this problem. Domain and range both are equal in this problem. Just observe that both are equal here. Domain and range both are equal. Now see here I have written all this. So this is a 3 marks problem. They may ask for 3 marks. Write all the possible values of R. It's R. Then after find the set of first elements is domain. The set of second elements in the ordered pairs is range. When the element is repeated, consider only one time. So domain is equal to this and range is equal to that 1, 2, 3, 4, 5, 6. Now, see the next one. 26th problem. The same problem I think almost we have done. This problem 2 times they asked for 2 marks and 1 time in 2017 they asked for 3 marks. F of x equal to x square. G of x equal to 2x plus 1 be two real functions. So they are asking here. Find this one. First one f plus g of x. So f plus g of x I can write, which is equal to f of x plus g of x. So f of x means x square plus g of x means 2x plus 1. That's all. For each problem 1 mark. 3 questions means 3 marks. The second one, f minus g of x. F minus g of x. I can write f of x minus g of x. F of x minus g of x. So you can write what is f of x square minus of g of x is 2x plus 1. So it will be x square minus 2x minus 1. That will be the second one, f minus g of x. When you are writing third one, fg of x, look at the third one. When they are writing third one, fg of x, they are given fg of x. Fg of x means f of x into g of x, just the product. You can write the product means I can write x square into 2x plus 1. You multiply 2x cube plus x square. Just you expand 2x cube plus x square. You will get like this fg of x, f of x into g of x. This is not n, consider as x only, f of x into g of x. F of g of x, the product of two functions. The fourth one, the quotient of two functions. When you are doing the fourth one, the quotient of two functions, they are given f by g of x. So I can write this one, f of x by g of x, but g of x not equal to 0. This is the condition. G of x not equal to 0. Then I can write, implies f by g of x is equal to, so what is f of x by g of x? I can write x square by 2x plus 1. But the denominator should not be 0. That here I can write by 2x plus 1. But we know that 2x plus 1 should not be equal to 0. X value should not be equal to minus 1 by 2. I can write x not equal to minus 1 by 2. X not equal to minus 1 by 2. I see here. X not equal to minus 1 by 2. So we got this. Because whenever to define any function, here denominator should not be 0. 2x plus 1 not equal to 0. X not equal to minus 1 by 2. So f by g of x equal to f of x by g of x, x square by 2x plus 1, where x not equal to minus 1 by 2. How you got, I explained here. Not equal to x not equal to minus 1 by 2. Please ask me if you have doubt again and again, I can explain. If you have doubt, please ask me again and again. No problem, I will explain again and again. If you have doubt, you can ask me again and again. If you have doubt, in the chat box, please send me your information, I can explain again. Yeah, because in chat box, let me know, I can help you. If you have doubt, please repeat the problem. Then I can explain. If you want to repeat, I can repeat the problem. No issue, I will repeat the problem. Okay, fine now. See the next one. 27th one. See the given here. A is equal to 1, 2, 3, 4, 5, 6. Define a relation R from A to A by R is equal to set of x comma y such that y is equal to x plus 1. X comma y belongs to A. Write down its domain and range. Write down its domain and range. A equal to 1, 2, 3, 4, 5, 6. A x and y belongs to A only. You can see here the relation y equal to x plus 1. That means you write the relation R Suppose you have taken element of x is 1. So what will become y? 1 plus 1, 2, 1 comma 2. It will become 1 comma 2. If x is equal to 2, 2 plus 1, 3. 3 like this, 3 plus 1. Because x you substitute here, in this you substitute here. 3, 4. It comes 4, 5. 5, 6. If I take 6 here, 6 plus 1, 7. 7 doesn't belong to A. So I can't consider this. Only this one is your R. Following the given condition, you find relation R. Now they are asking domain. When they are asking domain now, I can write domain equal to. In the given ordered pairs, the set of first elements is called domain. So first elements 1, 2, 3, 4, 5. I can write 1, 2, 3, 4, 5. This is domain. When they are asking range, the set of second elements in the ordered pairs. In this given relation, the set of second elements of the ordered pairs. Second element you can see 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Like this I can find range. So domain and range. Always they are asking find the domain and range. Write the roster form. This is called roster form of the relation. What I have written? This is roster form of the relation. Of writing the roster form, then I have written domain, the set of first elements of the ordered pairs, range, the set of second elements of the ordered pairs. That will be the range. I hope you understood this. If you have doubt, please let me know. I can explain again and again. In the chat box, please ask me. I can explain again and again. Now, see that the next problem. So 28th one. They given f from, they are talking about two functions. F from R to R and g from R to R are the functions defined by f of x equal x plus 1. They are given f of x equal x plus, f of x equal x plus 1 is given. And they are given here another one, g of x is equal to 2x minus 3. Then find f plus g of x, f minus g of x, f by g of x. First one. You take f plus g of x. So f plus g of x always can be written as f of x into g of x. This is like this they are given here. I can write f of x plus g of x we can write. F of x plus g of x. So then I can write, we know that f of x is x plus 1, g of x is 2x minus 3. Now like terms x and 2x, 3x. Just the given figure f of x plus g of x. You write x plus 1 plus 2x minus 3. It comes 1 minus 3. It will be minus 2. So this will be 3x minus 2. Correct. This will be x only. So 3x minus 2 is your answer here. Correct. Simple for 3x minus 2. Second one f minus g of x. So they are asking f minus g of x, the function f minus g of x. Simple you write f of x minus g of x. So f of x is x plus 1. When minus is here, you should be careful. Minus of 2x minus 3. Then if you expand this one, x plus 1, because you can write this is x plus 1 minus 2x plus 3. Then it comes now minus x, 1 plus 3, 4. That means 4 minus x. That will be 4 minus x. You will get like this, 4 minus x will be the second one. When I am going to do the third one, you observe here, just I am going to explain the third one. In the third one, they are given f by g of x. F by g of x is nothing but I told you, f of x by g of x. You should write this, but denominator should not be 0, I told you. Denominator should not be 0. If you follow this, I should write f of x is x plus 1, denominator 2x minus 3. But the denominator should not be 0, right? You remember 2x minus 3 should not be 0. So x should not be 3 by 2. Just to understand, I have written this one. Alright, x, because x not equal to 3 by 2. To define this function, x value should not be equal to 3 by 2. I hope you understood this, right? Because 2x minus should not be equal to 0. X not equal to 3, but I can write here function written comma x not equal to 3 by 2. When I define quotient function f by z, f of x by g of x, this is f of x by g of x plus 1 by 2x minus 3, where x not equal to 3 by 2. X not equal, I written this is x not equal to 3 by 2. X not equal to 3 by 2 I should write. X value should not be 3 by 2. I hope you understood this. Please ask me any doubts if you have. Please let me know in the chat box. I am here to explain again and again. If you have doubt in the chat box, you discuss with me. I can explain. I can repeat the problems. No doubt I will repeat the problems. If you have doubt, I will repeat the problems. Right. A is equal to 1, 2, 3, 4. B is equal to 5, 6. Define a relation R from A to here, A to B, by R equal to set of x comma y such that x belongs to A, y belongs to B, x minus y is odd. The given x minus y is odd. Since x minus y is odd, using that one we should find relation R. The given x minus y is odd. A is 1, 2, 3, 4, B is 5, 6. Now first we will find the relation R. So the R is equal to, I can write, you can start with x minus y is our difference. If we start with 1, difference of 1 and 5 is even number. We don't want. 1 and 5 difference is 4. 1 and 6 odd number I can consider. 1 comma 6, the difference should be odd. 1 comma 6 difference is 5 odd number. Now you compare with the 2 now. You take 2. 2, 5 odd number. If you take 2, 6, difference is even number, we don't want. You take 3, 3, 5, difference of 3 and 5 even number, we don't want. 3 and 6 odd number. You take 4, 5 odd number. You take 4, 6 even number, we don't want. Then this is 4, 5. So this is the required relation R. I will repeat how I have done this. The difference of x and y, is odd. So you take the first element 1, compare with B, 1 and 5, even number difference, 1 and 6 odd number. Take now 2 and 5 odd number, 2 and 6 even number we don't want, 3 and 5 even number we don't want, 3 and 6 odd number, like 4 and 5 odd number. So this is the required one. Now in this is called roster form. In this they are asking domain. So when they are asking domain here, so the domain equal to, I can write here, the set of first elements of the ordered pairs 1, 2, 3, 4. 1, 2, 3, 4. This is domain. The set of first elements of the ordered pairs, they are asking range also. When they are asking range, the set of second elements, you can write here, I have written the difference, you can see only 6, 5, 6, 5 is repeated. So 5 comma 6. In the set, no need to repeat the element. So range is equal to 5 comma 6. Domain is equal to set of 1, 2, 3, 4. Range is equal to set of 5 comma 6. Set of 5 comma 6. Now I'm going to explain the next problem now. So the next one I'm going to explain the next one. Check that. I'm requesting anyone, if any doubt, please ask me in the chat box. I can repeat again and again. Any specific question if you want, you can ask. I will repeat that. No doubt I will repeat that. Now 30th one. So let A is equal to 1 comma 2, B is equal to 1, 2, 3, 4, C is equal to 5 comma 6. Verify that A cross B intersection C is equal to A cross B intersection A cross C. So this is also most important one for 3 marks problem. First they are asking verify this result. First I will find B intersection C. Check that B intersection C. So B 5, 6 and is B, C 1, 2, 3, 4, C 5, 6. There is no common element. But you can see 1, 2, 3, 4. The given intersection 5, 6. That units, this is set of 5, 6. Then you can write, right? Because these two are designed sets 5, 6. There is no common element here. There is no common element. That means this is empty set. B intersection is empty set. Then you take the result LHS. You take LHS. What is LHS? A cross B intersection C. It will be A cross empty set. If you take Cartesian product with if you write Cartesian product of an empty set, because Cartesian product of A and empty set gives empty set. So the left hand side we got empty set. Now I am going to explain the right hand side. I will find A cross B, I will find now A cross B, A cross B. You easily can write what is A cross B. I can write A cross B, Cartesian product of A and B. Take now, I can write A cross B, 1 1, I can write 1 2, 1 3, 1 4. Take the element of A and take the element of B. Now I can start with the element of A, 2 1, I can write 2 1, 2 2, 2 3 and 2 4. So this is A cross B. Now find A cross C. Now A cross C. A cross C 1 5, 1 6, 2 5, 2 6. Check that. Any intersection is there, you can verify. RHS I to you, I will take RHS now. When I have taken RHS right side, or right hand side, you take right hand side. Correct? When you have taken right hand side, you can check that is LHS I have taken R right hand side. Right hand side is, we have right hand side A cross B intersection A cross C. When I have taken this, there is no common elements here. It gives empty set, no common ordered pairs. Therefore, I can write A cross B intersection C is equal to A cross B, correct, intersection A cross C. We proved this result. LH there again, otherwise LH is equal to RHS. Both are equal. I can therefore this is the conclusion. A cross B intersection is equal to A cross B intersection A cross C we can write. Like this I can prove this result. I hope you understood this. If you have any doubt, please ask me. I am here to explain again and again. I can repeat the problem if you have doubt. I will repeat because I am here to explain. Please ask me in the chat box if you have doubt. Is it clear? Yeah. Yes, Sanjana, which problem can I repeat? The same, just one. I will repeat this problem, Sanjana. Just I will repeat. Definitely I will repeat this one. Just now you can see that. So they are asking Sanjana just to repeat this. First you take B intersection C. B and C no common element. You can see B is having 1 2 3 4. This is here. We have 1 2 3 4. Correct. 1 2 3 4. So see here, there is no common element in this B and C, no common element. So I can write B intersection C is empty set. Take LHS, A cross B intersection C. So A cross empty set. The Cartesian product of any set with empty set gives empty set. Now you take A cross B. How did A cross B? You can write again this one 1 comma 2, 1 comma 1, 1 2, 1 3, 1 4. Next, now take 2 comma 1, 2 2, 2 3, 2 4. I got this. After that A cross C. So you take A cross C means 1 5, 1 6. Next 2 5, 2 6. Verify in A cross B, A cross C. There is no common ordered pairs. So you can verify 1 5 nowhere and 1 6 nowhere in this. 2 5 nowhere, 2 6 nowhere. No common ordered pairs. So intersection of these two will be empty set. Therefore LHS is equal to RHS. I hope you understood this. I hope is it clear? Then fine. Now I will repeat the next one now. So the 31st I will repeat now. So write the relation R defined as R is equal to set of x comma x plus 5. X belongs to 0, 1, 2, 3, 4. In roster form, write down its range and domain. They are asking write down its domain and range. So this is also a simple one. They are asking here Just you observe here in this problem, relation defined as x comma x plus 5, x is 0, 1, 2, 3, 4. They mention only x value. Substitute x value here, it gives roster form. I can write R is equal to set of, but x value 0, you substitute 0 plus 5, it will be 0 comma 5, substitute 1, 1 comma 6, substitute 2, 2 comma 7, substitute 3, 3 plus 5, 8, substitute 4, 4 comma 9. That's all, you write roster form. Like this x value they define, we got roster form. Now domain and range, they're asking domain and range. So when they're asking range, set of second elements 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. In the given ordered pairs, the set of second elements is known as range. Domain, the set of first elements. So don't be careful here. When they have taken set of first elements 0, 1, 2, 3, 4. This is domain. Domain means input. Range means output. After giving input, we get output. Output is called range. Input is called domain. Remember that. I hope you understood this right. Is clear. Please ask me if you have doubt. I hope you understood this right. Yeah, I'm going to explain the next problem now. The next one. See the next one. Let the relation of Z to Z be a relation defined by R is equal to set of A comma B such that AB belongs to Z integers. The difference is an integer. The saying difference is an integer. Show that all the three cases we should prove. We should prove that A comma A belongs to R when AB belongs to R, BA belongs to R, when AB belongs to R, BC belongs to R, A comma C belongs to R. This is one of the example problem. This is one of the example problem. Now see, problem is simple. Don't make it confusing. Very simple problem. This the given relation you see here. What is the relation is given? This is given here. The given R equal to A comma B. AB belongs to Z. The difference of those numbers belongs to Z. Prove these three. First I will prove the first one. Do you accept 0 belongs to Z? Is it true? Because always 0 is an integer. 0 belongs to Z. 0 meaning can I write A minus A belongs to Z. Because 0 belongs to Z, 0 is nothing but A minus A. So when they are saying here, whenever A minus B belongs to Z, A comma B belongs to R. You can see here, they mention here, when A minus B belongs to Z, then A comma B belongs to R. Here the meaning is here. So same thing, I got A minus A belongs to Z. So this is Z, belongs to Z, not to T, this is belongs to Z. So then I can write when A minus A belongs to Z, A comma A belongs to R, for all A belongs to Z. So first one is over. I read. So 0 belongs to Z, 0 means A minus K. So whenever difference belongs to Z, A comma B belongs to R. So I written A comma A belongs to R, for all A belongs to Z. So that they are asking first one over. Now coming to the second one. Just, I hope you understood the first one. Is it clear the first one? Now observe the second one now. When explaining the second one, they given whenever AB belongs to R, prove that BA belongs to R. Okay, first you take A comma B belongs to R. They given that A comma B, what they given you take A comma B belongs to R, you take. Because they told, consider AB belongs to R, prove that BA belongs to R. When AB belongs to R, this AB follows A minus B belongs to Z. I can write A minus B belongs to Z. That I can write. Whenever A minus B belongs to Z, remember, suppose 2 belongs to Z, even minus 2 belongs to Z, correct? You remember, suppose 3 belongs to Z, even minus 3 belongs to Z, correct? When 3 belongs to Z, minus 3 also belongs to Z. When A minus B belongs to Z, minus of A minus A also belongs to Z. Because Z is integer. Because when 3 belongs to Z, minus 3 also is an integer. So minus of A minus B belongs to Z. You multiply with the negative, it will come B minus A belongs to Z. So when B minus C belongs to Z, you observe here, when difference of A and B belongs to Z, A comma B belongs to R. When the difference of B and A belongs to Z, I can write B comma A belongs to R. Like this, I have completed the second one. Just verify. Please try to understand simple concept. When AB belongs to R, because sir, how you written this? Because the given definition here, A minus B belongs to Z. This is Z. When 3 belongs to Z, minus 3 also belongs to Z. 2 belongs to Z, minus 2 also belongs to Z. So this number is an integer. Minus of A minus B belongs to Z. Multiply with negative. B minus C belongs to Z. I got here difference of B and A belongs to Z. Then you see in the given relation, difference of A and B belongs to Z means AB belongs to R. But the difference of B and A belongs to Z means B comma A belongs to R. Like that we have completed. Now this is the addition here. You observe properly here. AB belongs to R. They are given. When AB belongs to R implies I can write A minus B belongs to Z. I can write this is 1. Again they are given B comma C belongs to R. Then they are given here. When B comma C belongs to R. When B comma C belongs to R, I can write B minus C belongs to Z. Correct. The given B minus C belongs to Z. So how you decide all this? Because that is a definition they defined like that. They defined here. Both belongs to Z. Now, see here, A minus B also integer. B minus C also integer. Again you think sum of two integers is again integer, right? Always you take any two integers, add two integers, it gives one more integer. Am I right? Sum of two integers is an integer. Sum of two integers is an integer. That you remember. Sum of two integers is an integer. Correct. Using same concept, if I add 1 plus 2, I can conclude here. Sum of two again integer. I can write A minus B plus B minus C, because A minus B plus B minus C belongs to Z. I have written after this. I added sum of two again integer. Now you can see here. I can cancel now minus B plus B. Then I will get now A minus C belongs to Z. Correct. When A minus B belongs to Z, A comma B belongs to R. When A minus C belongs to Z, I can conclude that A comma C belongs to R. This is A comma C belongs to R. Like this. This is an important problem. You can consider like this. I hope you understood this. Remember, this is integer. Sum of two integers, again integer. So that's the reason I have written. Sum of these two belongs to Z. This is belongs to Z. You observe here. Don't confuse. This is the belongs to Z. Implies A minus C belongs to Z. Then A comma C belongs to R. Is clear? Please ask me if you are doubt. I can explain again. Yeah, Ankur, I will discuss now. Just wait, Ankur. I am going to explain now. So, not like that ABC. See, Ankur, I will clarify now. So, Ankur is asking one doubt. They are not different C is an integer, they are talking AB. Ankur, the meaning is here. See here, they mention the meaning is B comma C belongs to or is given Ankur here. See, Ankur is given. See in this, you can verify here. The given B comma C belongs to or. You see this? B comma C belongs to or is given. Belongs to or, when the belongs to or the meaning, replace A with B, B with C, Ankur. The meaning is like that. I have not taken. Understood, Ankur? They are given B comma C belongs to R. When they are given B comma C belongs to R, replace A with B, B with C. Then all I can consider. Is it clear? Understood that? Yeah, that one Ankur I am telling. Try to understand, Ankur. The concept is, don't think it would only C. In the given relation, they are talking A comma B. Replace A with B, B with C. You can see A comma C. You can see here. you can go, you observe the relation here. When the relation, the given, suppose if A comma B, AB belongs to Z, A minus B belongs to Z. Here you see, third problem, the given A comma B belongs to R and B comma C belongs to R. See what the meaning of B, you observe here, when the given B comma C belongs to R, replace A with B, B with C. So you will get B comma C such that B comma C belongs to Z, comma, and I can write B minus C belong, automatically I can consider this. They mention here. So B comma C belongs to R means you replace, this is alphabets, because this is here, replace A with B, B with C. You take the meaning, you take any two integers. Ankur, is it clear? Consider any two integers. Understood, Ankur? Fine then. I will repeat now. The 33 problem now. So A equal 1, 2, 3, 5. B equal 4, 6, 9. Determine relation R from A to B by R equal to X comma Y. The difference between X and Y is odd. X belongs to A, Y belongs to B. The difference of X and Y is odd. They are asking only find the relation R. They are asking to find the relation R. I can find the relation R. The difference of X and Y is odd. X should be from A, Y should be B. Check that, you start with 1 comma. Check 1, 4. Relation is difference between X and Y is odd. So 1 and 4 odd number. You can take it. 1 and 6 odd number. Because 1 and 6 odd difference is 5. You take 1 and 9, difference is 8. We don't want that. Now start with 2. Because X belongs to A, Y belongs to B. Start with 2. 2, 4, difference is even number, we don't want. 2 comma 6, difference is even number. 2 comma 9, difference is 7. I can write 2 comma 9. Start with 3 now. If we take 3 comma 4, difference is odd number. 3, 6, difference is odd number. If we take 3, 9, difference is 6, even number we don't want. Now 5, 4, odd number. 5, 6, odd number. 5, 6, odd number. 5, 9, difference is even number we don't want. Like this. So this will be the R. They didn't ask domain and range. Even if they ask domain and range, easily we can write. They didn't ask here. Tell me what is the domain here. Just I am giving. Suppose we should familiar domain. They didn't ask here. Domain means here the first set of first elements. 1, 2, 3. I can write here. 1, 2, 3, 5. This is domain. What about range? In this you can see range is equal set of second elements. Only I can write 3, 6, 9, 3, 4. All the elements has come. From this I can write. Because they are asking here. See here. I have taken here the difference of this. Now you can see. I think something you can say again. I will repeat this. Something I written. We should compare the elements of, say, some mistake I have done here. You can see. Be careful here. So they are asking the elements X and Y, right? They are asking the elements of X and Y. So I have taken. You compare with 1, 4. I have written difference. I have written by mistake. So you can take it. You take 1 and 4 difference is 3, 1, 4. 1, 4. Again you can say 1 comma 6. Difference of 1 and 4 is 3. Difference of 1 and 6. Correct. Difference 1 and we don't want. Understood here. I am taking difference should be odd. 1, 6. I have taken 1, 4, 1, 6. 1, 9 difference is that we don't want. You take 2. If you take 2, 2, 4 we don't want. 2 comma 6 we don't want. 2 comma 9. Next you take this one. 3. 3, 4 I can consider. 3, 4. Difference is 3 and 4 is 1. Again 3, 6. I can consider difference is odd number. 3, 9. Difference is 6 we don't want. Correct. 3, 6. Next with 5. 5, 4 I can consider. 5, 4. I can consider 5, 4. Next 5, 6. I can consider 5, 6. 5, 9 we don't want. Because even number. So this is set of this. So this is the problem. Suppose if they ask domain, the set of first elements you write 1, 2, 3, 5, 6. If they ask 1, 2, 3, oh, sorry, we can do only 1, 2, 3, first of all, set of first elements 1, 2, 3, 5 only, 1, 2, 3, 5. They didn't ask here. Suppose if they ask a domain, the set of first elements 1, 2, 3, 5. 1, 2, 3, 5. If they ask range, here only roster form they are asking in this problem. Range means set of second elements 4, 6, 9. Again 4, 6, 9. You will get 4, 6, 9. Like this again, fine. After writing relation, we can write this. So this is a problem we have done here, right? Now 34. After 34, then I will explain the 5 marks questions. So 34. Just now observe here, the question number 34. In 34, what they are asking here, they are given f1, 1, 2, 3 ordered by 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 be a linear function from z into z, find f of x. The given linear function, they are asking find f of x. So here I can consider. So here you consider, let f of x is equal to ax plus b. So this is linear function. You take this one. F of ax plus b is the linear function. They mention here the values is given. F of 1 is equal to 1, meaning f of 2 is equal to 3. They are given this. F of 1 equal to 1, f of 2 equal to 3. F of 0 equal to, they are given minus 1. F of minus 1 is equal to minus 3. They are given. So how can you decide? So x is input. Output is this one, 1, 1, f of 1 equal to 1, f of 2 equal to 3, f of 0 equal to minus 1, f of minus 1 equal to minus 3. Now to find a and b values, first convenient, f of 0 equal to, I will take f of 0 equal to minus 1. Put f of 0, a into 0 plus b equal to minus 1. This I can write, b is equal to minus 1. We got b value. Correct? We got b is equal to minus 1. We got b value. We should find again a value. To find that any one of the equation I can consider. Take f of 1 is equal to 1. If you take f of 1 is equal to 1, so what can I write? Substitute a into 1. A plus b is equal to 1. But we know that b is minus 1. A minus 1 is equal to 1. A is equal to 2. We got a is equal to 2, b minus 1. Therefore, f of x is equal, I can write f of x is equal to 2x minus 1. This is the required answer. F of x, this is f of x equal to 2x minus 1. This is the required answer for 3 marks question. Maximum, this is expected question, question number 34. I am expecting they may ask this one for 3 marks definitely. Definitely they may ask for linear function, related linear function. They are going to ask my expected question now. Now, another, now 5 questions we have, only 5 marks questions I am going to explain. Always remember, if you attend my 2 videos, definitely you can score 15 to 20 marks only this chapter. In the previous session and today's session, if you solve it, definitely you are able to get, no doubt in that, 15 to 20 marks only this chapter. PUC, relations and function weightage, 15 to 20 marks. Try to remember, the marks weightage 15 to 20 marks. Damn sure you can score minimum 15. Maximum 20 in this chapter. Yesterday's session, today's session, you solve the problems, definitely you can score minimum 15 to maximum 20 marks. No doubt in that. Now, I will explain the 5 marks questions. See the 5 marks questions now. Define signum function. Define signum function. Draw the graph of the signum function and write down its domain and range. This is important problem. No doubt, you can expect 2 questions from this. I am explaining 5 questions. Damn sure 2 questions. What is a signum function? That is important. You write what is when they are talking signum function. You write the definition of signum function. Write everyone the different. Write everyone. Write be along with me. Write along with me. Signum function. The function f from R to R. The definition you can write. the function f from R to R. The function f from R to R defined by, I repeat, f from R to R defined by, right? Just I'm reading, there is a reason. Defined by the function, this is the function f from R to R. The function f from R to R, this is f from R to R defined by f of x is equal to, you write 1 x greater than 0, 0 when x is equal to 0, minus 1 x less than 0. The function f from R to R, this is R to R implies R to R, defined by f of x equal to 1 x greater than 0 comma this one 0 when x equal to 0, minus 1 when x less than 0. They are given like this. This is the function. I define this is the function defined by this one, you write E is called the signum function. I can write E is called, this function is called signum function. I can write signum function. That's all. It's called signum function. So definitely you will get the marks here. For 5 marks question, this one, you write the function called signum function. They will ask domain and range. Again they will ask graph also. The graph of the function, I will tell you that. Now you can see here, when they have taken this, what is the domain of this function? So domain means, I can substitute here, there is no restriction, x positive value, negative value, 0. All values I can consider, domain is equal to R, no restriction. What about the range? When they are talking range is equal to, you see, when positive it comes 1, when negative it comes minus 1, when 0 it comes 0, only 3 numbers, range is equal to set of, I can write minus 1 comma 0 comma 1. This is the domain and range. Now for this one key, domain and range 2 marks, definition again they will give 1 mark, and graph also they will give definition 2 marks, domain 1 mark, range 1 mark, graph will be 1 mark. Now I will draw the graph now. This is the easy, graph will be easy. Don't confuse this one. You write x-axis and y-axis. You can consider x-axis and y-axis. I can write x dash. Write x dash. This is y dash. So this one I can write, this is origin. So they are talking, see when positive number this is 1. So you put here positive number, this is 1. All that is 1 means I can check here. When they are saying here, when positive numbers, suppose this is, this is 1. So I can consider like this, excluding 0 when it is 1. I can write like this. So vice versa, right side. When x is positive, the value will be 1. This is 1 here. When x is negative, it will come like this. This is minus 1 here. Minus 1, it will go like this. Because I can write this is y is equal to 1. Output is 1. Here y is equal to minus 1. This is the graph of this. Here I can't include this value on y-axis. That is the reason empty circle I put here. That is empty circle. At 1, empty circle. Like this. So this is the graph of signum function. Why? Because at 0, 0 only. At 0, the result is 0. At 0, the result is 0. Correct. The result is 0. At 0, 0 only. So this is the graph of that. No doubt. 5 out of 5 you can get if we do like this. This is most important. I am expecting this question. This expected question for 5 marks. That will be enough. This expected question for 5 marks. That will be enough to write. What I have written, that part will be enough. That is enough to get 5 out of 5. Now, the next question I am going to explain the 5 marks question now. See the next question now. Right. Look at it. Define a modulus function. That's important. Define the modulus function. Define the modulus function. Draw the graph of the modulus function and write down its domain and range. Domain and range. This is also important one. No doubt. You can write the definition. The function f from R to R, I can write the function f from R to R defined by the function of from R defined by f of x is equal to, defined by f of x is equal to, again defined by f of x is equal to mod x. You write mod x, modulus of x. F of x is equal to mod x. F of x is equal to mod x. For each x belongs to R. For each x belongs to R. For each x belongs to R is called modulus function. For each, this is x belongs to R. For each x belongs to R is called, please, this is not n, this is x only. X belongs to R is called modulus function. Again, is called modulus function. Is called modulus function. Always they will define modulus function like this also. This is called modulus function. They will write f of x is equal to mod x. They will define when mod x equal to x, x greater than or equal to 0, minus x when x less than 0. Don't consider x is negative. Mod x is always positive. Sir, how I have written this? Because x is negative. Negative of negative is positive. So this is the modulus function definition. They are asking domain and range also. I will tell you now. Here you can see here the graph will come. The graph also important. They will ask graph of this one. I can explain the graph of this one also. So I can write this is x dash x and this is y, and here I can write down y dash. This is origin. The graph. See when x equal to 0, 0 only. It graph value, it never come down because this is the absolute value of x. It gives only positive values. The graph of this function comes only this one. I can write like this and it will go like this. Go both directions, it will go up. It moves upward. How much distance it goes? It won't come down. It passes through origin. So this is the graph of mod function. That's enough. It's extending up above how much distance we can do that. So here what is the domain of this function? When they're talking domain of this function, I can write domain equal to, there are no restriction, all x values I can consider. Domain is equal to set of real numbers R. What about range? When you're talking range of this, see here, it never be negative values, including 0 up to infinite values. So range will be 0 to infinity. Starting value 0. You will get only positive values. See, you never get negative values. This is range. Domain equal to R. Range is equal to left closed, right open. Infinity said always right open interval. Since including 0, this is left closed, most important. If right left side also open, they will cut 1 mark. So left side including closed bracket, right side open bracket. Try to observe here what I have written the range. I hope you understood this. Is clear? These are the 5 marks. What I have written, that will be enough. The 5 marks question, what I have written, that part will be enough. I hope you understood this. Is it clear? The 5 marks questions all? Please ask me to repeat in the chat box. I will repeat again. Is it clear? If you want to repeat, I am going to repeat any number of times. Because in this chapter, maximum marks you should get it. Either 20 out of 20, like 15, minimum 15, maximum 20 marks you will get in this chapter. You should get out of out. No, CBSE questions, derivation they won't ask. In CBSE, only they will ask, See, in CBSE, they will ask only application part. Like domain, range, they will ask. CBSE, in this question, they will ask, what is domain, what is range? That they will ask. In PUC, they won't ask, in PUC, they will ask definition, figure and everything they will ask. But in CBSE, only application part they will ask, what is domain, what is range? They may give graph. Look into the graph. You decide what is domain, what is range. They may ask. Okay. Now that question number 38. It takes another 5 to 10 minutes to complete that. So define an identity function. Draw the graph of identity function and write down its range and domain. They're talking about identity function. Define an identity function. Draw the graph of the identity function. Write down its range and domain. This is also most important. So what is the identity function? I will write now the definition of that you can write. I can write the definition of this. You can write. We can write the real valued function f from R to R. I can write the function f from R to R. This is the function. You can try to understand the writing here. The function f from R to R defined by y is equal to f of x is equal to x. This is y is equal to f of x is equal to x for each x belongs to R. For each x belongs to R, for each x belongs to R, for each x belongs to R is called the identity function is called the identity function. For each x belongs to R is called the identity function. I can write is called the identity function. So they will say identity function. Is called the identity function. Remember y equal to f of x equal to x. That point is remember. This point is important here. Y equal to f of x equal to x. For each x belongs to R is called the identity function. That means input output is same. Input output will be same here. Remember input output will be same. That is called identity function. Input output both are same here in identity function. That you should remember. That means what is the domain of this? So domain is equal to R because the input f of x every x I can put here. Output also same thing. Then range also R. The range also set of real numbers. Both are equal. Domain R equal to R, range equal to R. What about the graph of this? The graph is a straight line because point x comma x. You see y equal to f of x equal to x. X comma the points are input x, output x, x comma x. So think about the graph of this function. It gives a straight line passing through origin. Straight line passing through origin. I can write x dash x. This is y. This is y dash. Passing through origin I can consider. This is passing through origin. So this is the graph. It gives a straight line. So how can you know that? Because output input are same. X comma, the meaning is x comma x. 1 comma 1, 0 comma 0, all the points will be, it gives a straight line. You can write the graph is a straight line. The graph is a straight line. That also you can conclude that. The graph is a straight line. 5 marks, this will be enough to get the 5 marks. You can write the graph is a straight line. You will write here. The graph is just passing through origin, right? The graph is a straight line which passes through origin. The graph is a straight line. Is a straight line which passes through origin. You write which passes through 0, 0, right? Correct, which passes through origin you write here. Which passes through origin. Please try to understand which passes through origin. I will repeat this. The graph is a straight line. The graph is a straight line which passes through origin. The graph is a straight line which passes through origin. You show the graph here. That will be enough. I hope you understood this. Is clear? So another 2 more problems, another 5 minutes it takes. Is clear, understood that? So the graph and the things which is required you write that. That will be enough for 5 marks. Now I am going to explain the next one. See the next one, define the greatest integer function. Draw the graph of the greatest integer function and write down its domain and range. Greatest integer function. Write down its domain and range. This is also important problem here. They are asking greatest integer function Draw the graph of the greatest integer function. Some people they will say step function. What is the definition of this? I will write the function. You can write the function f from R to R. The function f from R to R defined by the function f from R to R defined by f of x is equal to, this is called step x. Step x inside x closed brackets. I can say step x. Step x, x belongs to R. Step x, x belongs to R. So you be careful. The function f from R to R defined by f of x with step x. How to read step x? X belongs to R. Assumes the value of the greatest integer. Assumes the value of the greatest integer. Assumes the value of the greatest integer. The value of the greatest integer. The value of the greatest integer less than or equal to x. Less than or equal to x. Less than or equal to x. I will repeat. The function f from R to R defined by f of x equals step x, x belongs to R, assumes the value of the greatest integer less than or equal to x. That is called greatest integer function. I can write here equal to x. Now, such a function, this function is called greatest integer function. This function is called, you can write greatest integer function. Greatest integer function. This function is called greatest integer function. Because I should draw the graph here. This function is called greatest integer function. Greatest integer function. What is the domain of this? So it gives only output will give integers. Output gives only integers. So domain means R. I can write no restriction. Domain is R. Any number I can substitute, domain is R. Then you are taking your range. When you are talking about ranges, it gives only integers. So range is equal to Z, I can write. So range is equal to only Z it comes. Range is equal to Z. Domain is called range is equal to Z. So what is the graph of this one? You should be careful to draw the graph of this one now. So here, just observe here. The people may confuse but try to understand. The graph will be simple. I will explain here. Many points is not required. Just see the graph of this one. The graph will get. When they are talking the graph of this one, I can write x-axis and y-axis. Y dash and y I can consider. So this is can consider as x and x dash. Right. This will be, I can write origin, I can consider. This is origin. I can put the points here. This is 1, this is 2. I can write here also points. I can write 1, 2, 3 I can write. This is also I can mark the 3, I also can mark the points. I can write -1, -2, -3. Please go through the textbook also. If any clarification, go to the textbook, the figure, if you have any confusion. So what is the meaning here? If you take any number between 0 and 1, step function meaning, if you take any number between 0 and 1, it gives 0 only, it comes this only, except 1, it won't come 1 here, except 1. Between 0 and 1, if you take, the value comes only 0, it comes. Now if you take between 1 and 2, except 2, it comes 1 only. Between 2 and 3, it comes 2, between except 3. Coming to here, suppose you take between -1 and 0, so be careful. You may confuse between -1 and 0. You also can write the number -1. I can write denominator also. This is -1. This is -2. Between -1 and 1, I can consider this except this number. Between -2 and -1, that will be -2 only it comes, except like this. These are the values. This is the graph of this. Please verify the textbook. Please verify the textbook. Page number 42 for the graph. Page number 40, verify the graph. To understand the graph again, if any confusion, please refer page number 42 in the textbook. This is the graph. domain and range. Learn this one. Leave it this one. Pakka you should learn. Maximum, this question asks number of times they repeated. Many number of times they repeated this. So try to learn this. Don't leave that. I'm explaining 5 questions, 5 marks questions. 2 definite, 10 marks. No doubt in that. You can expect that 2 questions from that. Now see that now. The last one. Define constant function. Define constant function. Draw the graph of it. Also write domain and range. They are talking about the defined constant function. Right, the function f from R to R. I will write here. The function f from R to R. The function f from R to R defined by, this is arrow mark, R to R. I can say R to R. Defined by y equal to f of x equal to c. Y is equal to f of x is equal to c. X belongs to R. X is a real number. Where c is a constant. 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 Is called the constant function. Defined by equal to f of x to c. X belongs to where c is a constant is called constant function. What is the constant function? Output, in output there is no change. That is called constant function. You write f of 1 equal to c, f of 2 equal to c. There is no change in output. That's why that is called constant function. What is the domain of this? I can write domain is equal to anything I can substitute here. You can think when they are talking domain here, no restriction, any number I can substitute, so set of real numbers. What about range? Range only you will get output is, there is no change in output. Output is fixed. Singleton C. Output is singleton C. Because whatever you write in the place of x, there is no change right hand side. That is called constant function. So domain is equal to R, range is equal to C. Sir, how to draw the graph of this? To draw the graph, I will tell you one example here. I can consider example. You take example. Let f of x is equal to, you take some 2. So you write f of 1, 2, you can verify. F of 1, 2, f of 0 to anything will be 2 only. There is no change. They have written f of x is equal to 2. So what is the graph of this one? You can see the graph I will explain now. You take x-axis and y-axis. So this is x-axis, x dash. This is y, y dash. Take y, y dash. Y, y dash. Now you put this is, I can consider. Now I can see here, I can write, this is origin here. You took f of x is equal to 2. What is f of 0? 2 only it comes. It will be 2. I can write it, this is 1, this is 2, this is 0.3 I can write. If you put f of 0, it comes 2 only. F of 1, it comes 2 only. It gives a straight line passing through 2. So f of 1, f of 2, f of 3. You take minus 1, minus 2, minus 3. There is no change. Okay, whatever you write, that will be 2. You write f of 0, 2 only. F of 1, 2 only. F of 2 also 2 only. F of anything, whatever you write, it will be 2 only. I can draw the graph f of minus 1, 2 only. Whatever you write, it will become right side, there is no change, 2 only. Here, that is the reason you will get a straight line which is parallel to x-axis. It's a straight and parallel to x-axis. So this is the I can write y is equal to 2. So y is equal to 2, f of y is equal to 2. To understand, I give an example. There is no change right hand side. So this is the graph of this. So you get 5 out of 5. Domain is R, range equal singleton C. So should you learn this? This is the example I given, y is equal to 2. The graph is, you can write the graph is a straight line. You can write the conclusion. The graph, here you can write the graph is a straight line which is parallel to x-axis. Right at that point you can write the graph is a straight line which is parallel to x-axis. The graph is a line parallel to x. You write that one. The graph is a line parallel to x-axis. You can include that point. The graph is a line parallel to x-axis. just you write that word. The graph is a line. The graph is a line parallel to x-axis. Parallel to x-axis. The graph is a line parallel to x-axis. Please understand my, because I am saying, try to understand. The graph is a line parallel to x-axis. The graph is a line parallel to x-axis. Today's the last problem. So with this, just another 2-3 minutes it takes. I am going to complete the session. With this I can complete now the last problem now. See this. Define a rational function. Draw the graph of f of 1 by x where x belongs to r minus singleton 0. Write the domain and range. Write the domain and range. They are talking about the rational function. Rational function. So you can write rational function or functions of the type. You can write the function of the type f of x by g of x. I can consider the function of the type. The function of the type f of x by g of x, f of x by g of x, where f of x and g of x, where f of x and g of x are polynomial functions, of x, all functions of x defined in a domain. Defined in a domain where g of x not equal to 0, where the denominator g of x not equal to 0 is called rational function. This is called rational function. Again, this is called rational function. What the domain and range? I can write now domain equal to the given function f of, they are asking that one. What the graph of f of 1 by x? I will tell you the graph also. The given function f of x equal to 1 by x. What the domain? They mention here x belongs to r minus singleton 0. That is called domain. Input is given clearly. They all in the problem itself they are given domain. Please observe here. This is the domain of the problem. I can write domain equal to r minus singleton 0. When they are talking range, so range also you see f of 1 by x, the meaning y equal to 1 by x. From this I can write x is equal to 1 by y. You can do the cross multiplication, x equal to 1 by y. Here also y should not be equal to 0. The output also should not be 0 because y is output. So I can write here range is equal to same thing, r minus singleton 0. Same thing we will get the r singleton 0, range is equal to r minus singleton 0. So here for reciprocal function, or this is called f of 1 by x for reciprocal function. I can also say rational function, reciprocal function here. Range is equal to this, domain is this, and range is this, r minus singleton 0. They are asking about the graph of this. So you observe the graph. Just when you are considering the graph of this, just observe with the graph I will complete this. What is the graph of this one? So when they are talking about the graph of this one, you take this one, x-axis and y-axis. I can consider. So y-axis, y dash, x dash and x. Correct, this is a graph here. So I can, this is origin. Correct. That when they are asking graph y equal to 1 by x. So it never be, see, when x equal to 0, it goes approaches infinity. When x equal to 0, this is 1 by x. So when x approaches to 0, it goes to infinity. So when x approaches to, you can see, when x approaches infinity, y value goes to 0. Remember here, when x approaches to infinity, y approaches to 0. When x approaches to 0, y approaches to infinity. Y approaches to infinity. The graph will come like this. The graph here, you observe here. The graph will be like this. Nearer to x, this one. This side, when the negative case, the graph will come like this. Like this. One is the image of the other with respect to origin. The graph nearer to this it will come. Nearer to that. The graph nearer to come like this, passing through like this. This is graph of y equal to 1 by x. Understand? It will come like this. It's like this is the graph of this. So with this I am going to complete today's session. I completed this one. So the chapter, I completed the entire chapter. I completed. So please go through this. Do it again sincerely, all the problems. No doubt. You get maximum out 20, minimum 15 you get in the coming PU board exam. This is the weightage 15 to 20 marks. No doubt in that. The next session, tomorrow I am going to explain trigonometric functions. Tomorrow topic, trigonometric functions. Trigonometric functions at 6 p.m. Thank you. If you like the session, please like it. Any specific topic if you want, please send me in the comment box. You write, not in the chat box. In the comment box you can write any particular topic if you want, any specific doubts. Please write in the comment box. Not in the chat box, please write in the comment box. I can explain the particular topics. If any particular topic if you want, let me know in the comment box, not in the chat box. Your comment box also is there. Write in the comment box. I can help you. If you like the session, please like it now. See you tomorrow at 6 p.m. See you tomorrow at 6 p.m. Yeah. If you like the session, please like it. Fine, later. Yeah, the comment box will come after that. The comment box, after you come out, the comment box will come. You can see that. Fine. Then see you tomorrow then. Yeah, Ankur, no problem. Comment box will get later. You can see that. If it is helping to you, please forward to your friends. They can also, anyone they can join. Please forward to your friends also, even if they want. They can also attend the class. Then, bye bye. See you.